All right, welcome to our last lesson in this unit. This one is in factoring something specific. We're going to look for some perfect square trinomials. So the previous lesson was the difference of squares, where the middle term had dropped out, so we didn't have a middle term. That's what we were working on last lesson. Today we're going to work on these, where I do get a trinomial. I get three terms, but that middle term is really just double of the same amount. I kind of got two of the same number as my middle term, and I kind of got multiplied by 2. That means it was really just the same binomial being multiplied twice. So this was a plus b times a plus b. When I do a times a, I get a squared. When I do b times b, I get b squared. But in the middle, I get an ab and another ab, so I really get two ab's. When we can find that pattern, we can very quickly factor this one without too much work. It's just knowing what to look for and then how to put it to use. So here's kind of our checklist. First, start with my first term, ax squared. Is that a perfect square? If it's not, this isn't going to work. Or maybe we need to factor something out of it first to see if it can work. Then look at your last term, c. Is it a perfect square? If those two are, then we've got a good chance of making this work. And then the real work is going to come down to, is my middle term 2 times the a and the b? Okay. So let's see that in action. So I've got x squared. Is that a perfect square? Yep, it's x times x. Is my last term c a perfect square? Yep, that's 8 times 8. And then I check the middle term. Is the middle term 2 times my a times my c? Okay. Well, 2 times x times 8 really is 16x, so this one's going to work. So I know it can work. So what that tells me is I'm going to get two of the same problem. Okay. I have plus for my last term, but minus for my middle term. So that means it was a minus minus. To get x squared, I do x times x. To get 64, I do 8 times 8. And then my middle term is going to be a negative 8x and a negative 8x, which is that negative 16x. So this is really x minus 8 squared. It's the same binomial being multiplied times itself. Okay. So let's check the next one. Is my first term a square? Yes, m times m. Is 25 a square? Yep, 5 times 5. Is my middle term 2 times my m times my 5? Yeah, 2 times m times 5 is 10, or 10m. So that means it's going to follow my perfect square pattern, meaning m is going to be my first term, 5 is going to be my last term, and then it was plus and plus, so I know it's going to be m plus and m plus 5, meaning it's really m plus 5 squared. So we don't have to go through all the other steps of trying to figure out what do I want to multiply together and what should those terms be. If it follows this pattern, we know it's one of these perfect squares, and we can just go ahead and factor it out. All right, check the next one. P squared, yep, that's p times p. 64, yep, that's 8 times 8. Is my middle term 2 times p times 8? No, it's not. Okay? So for this one, it's not going to fit to my pattern. But that doesn't mean we can't factor it. We just got to figure out, is it possible or not? So notice this part up here. Just because it doesn't fit this pattern doesn't mean it can't be factored. It just means we got to try some of our other strategies. So this one has a 1 in front of the p squared, so it's just kind of one of my basic ones. So let's see if we can factor it. It's a plus and a plus. I need something that multiplies to give me 64. So 1 times 64, 2 times 32, 4 times 16, 8 times 8. And I need them to add to be 8. Do any of those possibilities add up to be 8? No. In this case, they don't. Okay. So this one is actually going to be prime. It didn't fit my perfect square pattern. It also doesn't fit any other tactic that I have, so this one can't be factored with our whole numbers right now. All right, so let's see a couple of these. So for each of these, we're going to factor the polynomial if possible, and then tell me which rule we used. It might be today's rule, it might be yesterday's rule, okay? It can depend. So first one, 98x squared minus 200y squared. So this tells me that I might want to look at using the difference of squares. That's what we were doing yesterday, because I don't have a middle term. The problem is, right now I don't have any perfect squares. 98's not a perfect square, neither is 200. So first check, could I factor something out? And I can. I can factor out a 2 from each of those. Okay. Now I take a look at it. Do I have any perfect squares? Well, yeah, this is 7x times 7x. This is 10y times 10y. So I can do 7x minus 10y and 7x plus 10y. Okay, that's my difference of squares pattern. All right, take a look at the next one. Okay, it's got 3 terms, so this might be one of our perfect square ones. This one is a perfect square, x times x. This one's a perfect square, 11 times 11. So now check the middle term. Is my middle term 2 times x times 11? Yeah, it is. So that means this is one of my perfect square ones that we were just working on. It's plus and plus, so I know it's going to be x plus 11 and x plus 11, which is really x plus 11 squared. So this was one of my perfect squares. Let's check the next one. Again, it's got 3 terms, so it's not going to be the difference of squares, but let's see if it is our perfect square trinomial. This one is a perfect square, 9 times 9. This one's a perfect square, j times j. Is the middle 2 times 9 times j? Yeah, that does give me 18. So I can use my perfect square rule to factor this one out quickly. This is really going to be 9 plus j and 9 plus j, because it was both plus and plus, which is really 9 plus j squared. So if we can find these patterns and if we can find these rules, it can make our lives a lot easier. So let's try the next one. So this one is 5c times 5c. This one is 1 times 1. But I can't have a minus from the last one. A minus as the last one says it's gotta be a plus and a minus for my 2 pieces. So this one can't possibly be one of my perfect squares, because I've got to have the same sign for both of them, so that one's not going to work. So now we look for some other strategies. Okay? What could I multiply to try to get 25 and 1? Well, this is where I do my a times c. So ac is 25. So I could do 1 times 25. I could do 5 times 5. But one's got to be plus and one's got to be minus. There's no way for those to combine together for either of those pairs to subtract, so this one's going to have to be prime. All right, let's check the next one. So this one is 13 times 13. This one is r times r. Okay, so that works so far. My middle term, well, that's 2 times 13 times r. So that works. This one can be my perfect square. Okay. So I can break it out. Since I have a minus in the middle, I know this was a minus, minus. And I have 13 minus r and 13 minus r. Remember, if it fits that perfect square pattern, we know it's the same binomial twice, which is really 13 minus r squared. All right, last one. So 7 is not a perfect square, so I can't use that pattern, so it's not going to be one of my special ones. So I just try to see if I can just factor it like normal. So I take a times c, that's 14, so I can do 1 and 14 or 2 and 7. Okay. I have a plus for the last term, so that means my signs are going to be the same. I have a minus for the middle one, so it must have been minus, minus. which is the only combination that's going to give me 9? Well, that would be a minus 7x and a minus 2x. So the rest of the problem slides down. And now we do our factor by grouping. I can factor out a 7x, and I get x minus 1. Here I can factor out a minus 2 and get an x minus 1. Okay, so I just factored each one of those, or each pair. So one of my terms is x minus 1, and one is 7x minus 2. So it didn't fit any of my patterns, so I go back to some of my other strategies. All right, last ones. And I'm just going to do a couple of these. Now that we know the patterns, now we start to look for how can we tackle this. So this one is x times x. This one is 2 times 2. Okay, my middle term, 2 times x times 2. Yep, that works. So I know this is going to be x plus 2 times x plus 2. It's my perfect square. So I set each one equal to 0. In this case, they're both the same, so I really only need to do it once. X plus 2 is equal to 0, so x is equal to negative 2. Because I'm really going to get the exact same answer again for the next one, so I don't need to solve it twice. Next one, 16n squared plus 16n plus 4. So you might notice that I have a common factor in all of them. I could divide a 4 out of all of them. So I get 4n squared plus 4n plus 1. Now I check to see if it fits my perfect square. Well, this is 2n times 2n. This is 1 times 1. So the real test is the middle. Is this really 2 times 2n times 1? 2 times my first term times my last one. Well, yeah, that does 4n. So I know this is going to give me 2n plus 1 squared, because it's going to fit that perfect square pattern, 2n plus 1 and 2n plus 1. But I got to solve it, so I go ahead and set them equal to 0. 2n plus 1 is equal to 0, so n is equal to negative 1/2. Okay, remember, if you need to show that work, that's okay. So I'd get 2n is equal to negative 1, I divide them each by 2, and that's how I get my negative 1/2. All right, so I'm going to do one more of these for us. So take a look at number 13. So it's a trinomial, so let's see if our perfect square works. This one is g times g. 1/9 is really 1/3 times 1/3. So it is perfect squares in either end. In the middle, do I have 2 times g times 1/3? Yeah, that's 2/3. So this is going to be one of my perfect squares. So my first term is going to be g. My second term is going to be 1/3. And it's going to be 2 of those same expressions. Set it equal to 0 so I can solve it. And g is equal to negative 1/3. In this case, I'm going to get the same solution twice, so I really just have to list it once. All right, hopefully that makes sense, and we'll practice some more.